Hello everybody, so I'm back. I decided to create one more tutorial to show you how you can apply the stretchy arm concept on this rig that I have created. This is the same rig that I went over and I made a tutorial for you guys to show you how you can set up the curvy band and also a normal band, and also how you can blend between them, as well as the FK mode using one switch here. So right now everything is set up. This is the IK controller, and on the hand extra controller I'm having this bend mode that you can switch between normal IK and bend and curvy bend, as well as if you want you can switch to FK mode. So the FK mode is also set up. So we are back now in IK, and then for the IK we have two options, either curvy bend or normal bend. Again, this is following the tutorial that I have created for how we can set up this kind of curvy bands on a given character's arm. So I'm following the ribbon method for the whole tutorial here. So let's go back to the default pose on all of these controllers. I'm going to zero out all the values. All right. So let's see how we can set up the stretchy arm for not only the normal IK, but also how we can apply the concept to the curvy band, and also how we can create another attribute or create another setup that makes sure that we are preserving the volume on the arm here. So let's start by going to the node editor. The concept here is that we will first see what is the default distance between the arm shoulder and the current position of, or the default position of the IK handle or IK controller. Then we are gonna find that distance. We will use that as the default distance, and then using that default distance we are going to calculate the scaling factor using some multiply divide node inside the node editor. So let's start by creating a distance node. So I'm going to go to create measure tool, distance tool, and I'm going to hold down V to create two locators, one in the arm joint position and also another one in the IK controller position. So the first locator, I'm going to name it left arm distance locator, and the other one is left hand distance locator. And I'm going to name this left arm, maybe stretchy distance, or yeah, distance. All right. I'm going to go to my node editor by going to Windows, node editor. All right. So here are the two locators that we have created, and also the distance node that will be created automatically. So I'm going to remove these nodes, extra nodes here, we don't need them. So if I take a look at this distance node here, you can see that it has two inputs, which are actually the position of the two locators that we have created, and it will give us the distance. This is the default distance for this given character's arm. We are going to use this default distance in couple places. So let's see, first of all, we have to copy this number. I'm going to select it and hit Control C to copy the number. Then I'm going to create a multiply divide node. I'm also going to create a condition node. So in the condition node, we are going to use the distance here. First, we are going to, for the condition node, you can see that we are having two inputs, and then we can apply an operation on them. And based on the result of this operation, either if this is true or false, we can send out some outputs from this node. So the first term on this condition node is going to be the current distance between these two locators. So I'm going to use the output here, which is the distance, and I'm going to plug it into the first term. The second term, we always want to compare this number by the default value, which is 6.517 for this character. So I'm going to type in that number. And then I'm going to say if the first term is greater than this default value, then do something. If it is not, do something else. Before that, I'm gonna, because I think I forgot to make the point constraint on these two locators, I'm gonna make sure that these two locators are always going to follow the joint and also the controller. So for the first locator, I'm gonna select the normal arm IK joint. Then I'm gonna select the locator and go to constraint, point constraint, and make sure that maintain offset is off. We wanna not only create the point constraint, but also snap them together. So I'm gonna hit apply. For the second one, you have to make sure that you're using the controller, nothing else, not the IK handle, not the joint, nothing. We wanna be able to calculate the distance between the controller and this joint. So I'm gonna select the controller, select the other locator, and create another point constraint, apply. All right, so now, when I move this controller, the IQ controller, this second locator is going to follow that. And now here, if I go back to my distance node, you will see that the distance now is different. So the distance here is different. We are comparing this distance to the default distance, which is 6.517. This is greater than that, yes. So we are going to send out this current distance. So I'm going to use this in the condition node again. Color if true. I'm going to use just the first term. I'm going to use the current distance. So it's comparing the current distance by the default distance. If it is greater than that, it will send out the current distance. If it is not, it will send out just the default value. All right. Now we are going to divide the current distance. So I'm going to use the current distance again. And I'm going to divide that value by the default value. Again, I'm pasting that number. So I'm using this default number over and over in a couple places. Make sure that you change the operation to divide. I'm not sure if I checked this one. Yep, okay, this is correct, greater than that. So if the first term is greater than this number, send it out. If it is not, just send out the default value. Here, we are using that the current distance and dividing it by the default distance. All right, so this is actually the scaling factor. Scaling factor. I'm gonna name it left arm stretchy scaling factor. All right, so the output of this divide node is going to be connected to the scale of the normal IK joints, and only we are going to connect that to the scale X of these joints. If your joint orientations are different, you have to choose the correct scale. For this given setup, I'm going to just scale up these joints in X direction. So I'm going to load this joint here, all of them actually. I'm going to add them to the node editor. We don't want to see these, so I'm going to select these two and remove them. Bring this up. Hit 3 to expand them, and I'm going to use the output X of the scaling factor and connect them to the scale X of these three joints. All right, let's test it out. I'm guessing we are not in the normal IK mode, so I'm going to switch to normal IK mode. Here we go. Apparently my condition node is not working properly, so let's double check that. Condition. Okay, there's something wrong here. I directly use the distance in the divide node. I have to use the output here. So I'm back to my condition node. I'm going to use the output of the condition and plug it into the input of the divide node. So this is wrong. I'm going to remove this and I'm going to use the output color here. All right. Now let's test it out. This is the default pose. If the distance between these two locators are less than the default pose, nothing is going to happen, so it will act normally. However, if we pass or go beyond that distance, it's going to stretch out these three joints that are scaling up the ribbon, which is here. Here's the ribbon. And the ribbon holds the joints, the bind joints, and the bind joints are gonna stretch up the geometry for us. All right, cool. You have to do the same thing for the curvy IK joints too. So these are the curvy joints, and we want to make sure that as soon as we pass the default distance, all of these curvy joints are going to be scaled up. So we're going to do the same thing. We're going to use the scaling factor here. This is the output, and we're going to connect the output of it to all of those curvy bend joints, all of these. And again, you should double check and make sure that you're using the correct axis first for these setup. So these joints, we have to just scale them up in the X direction. However, you are seeing that we are having 11 joints here, which is too much, and there's a chance that we are going to mess up with these connections. So I'm going to make one of them manually, and I'm going to show you how you can automatically create those connections by just creating one line of code. So I'm going to expand this. I'm going to bring up the script editor, delete all of these, go to a new tab. So I'm going to do it once, and then I'm going to copy the code and bring it down here and put it inside a for loop. So the output of the scaling factor is going to be connected to scale X. This is the code for that. Then I'm going to put this inside a for loop for a joint inside a list of selections. Connect attribute the output X of the scaling factor to every single joint that I will select. Alright, so we just need to select the joints. The first one we just created manually, so I'm going to deselect that. And for the rest of them, I'm going to select or highlight these 3 lines of code and hit run. The connection is made for all of them, just to double check. We didn't get any error here, and as you can see, all of these connections are made. And now let's check it. This is the normal IK that we previously created, and if we switch to the bendy arm and then start moving the IK controller, you'll see that the arm is going to be stretched. All right. So one more step that we can add to this setup is that sometimes we want to make sure that we are preserving the volume of the geometry. So when you are stretching something inside the 3D space, just to make it more believable, you have to apply a volume preservation for that stretchy geometry. So we took care of scaling up these joints in X direction. We just need to scale them down in Y and Z direction. So we are going to use the same scaling factor here that we have found, and we are going to divide it by 1 and then use that output for the other 2 axes. So I'm going to remove these joints again. We don't want to see them. for now. I'm gonna use this output. I'm gonna create a multiply divide node. I'm gonna use the output here, put it inside, put it to connect it to the input x, input 2x, and here I'm gonna say I want to divide 1 by that value. So divide 1 by this value. Then I'm gonna use this, the output, and connect it to the scale y and z of the bind joints. Not these joints, but the bind joints. So I'm gonna load the bind joints. Load them here. And again, I'm gonna just do it once for one of them, and for the rest of them, I'm gonna write down the script for that and run it through the scripts. So I'm gonna just select the first joint. Again, double check and make sure that you're using the correct axis. Again, for these bind joints, apparently we have to just scale them down in Z and Y. All right. Hit 3, scale output to Y and Z, just to be able to get the code for that. So I have just manually connected them together. I'm gonna copy these 2 lines of code. And again, copy this for loop. It's connecting the output x of the new multiply divide node to scale y and z of the joint 01, the bind joint 01. So I'm gonna replace this with joint. And then I'm going to select all these extra joints and run the code. No error, good. The connection is made. And now let's check it. Here we go. Not only the arm is stretching, but also the bind joints are squashing in. So we are scaling them down in only y and z axis. It's supposed to work in both IK modes, so I'm gonna switch to the other mode. All right. Awesome. And in order to be able to have more control over this this scaling down effect here, we can actually create another extra attribute on the hand extra controller, and I'm gonna name it maybe volume multiplier. I'm gonna put a minimum of 1 for that. Okay, so the attribute here is here, and I'm gonna connect it to the multiply node that I have created for the volume preservation. So I'm gonna bring it up, load this controller in my node editor. Here's the new attribute. I'm gonna put it or connect it to the input yx here. Okay. So by default, the value is set to 1, which means that it's going to preserve the volume. However, if I'm not happy with the way it's stretching down, I can always play with this multiplier and scale it up and down. Maybe we can even remove the minimum value that we have defined for that, so we can also scale down the joints even less than to values less than 1. Okay, here we go. Awesome. So the default value 1, and I'm going to remove it back to the default pose. And again, it's supposed to work in both bendy modes. Hello, so I'm back again. I realized that there is a small issue in the current setup that I have created for the squash and stretch setup here. So you can see that, I mean, in IK mode everything is working perfect. So when I'm let me actually switch to IK mode, and when I'm in IK mode everything is stretching and also squashing. The preserve volume multiplier here is also working, so if I'm not happy with the way it's actually scaling down, I can always play with this attribute here. However, the issue here is that because I directly connected this node, which is the division of 1 by the scaling factor, to reverse or scale down the bind joints in Y and Z axis, I did not take into account the effect of the IK-FK switch. So it means that regardless of which behavior I'm at, either in IK or FK, you will see that the IK controller or all of these setups here are going to still affect the scale of the bind joints, which means that now if I play with the controller, with the IK controller in FK mode, so I'm in FK mode, however, this IK controller is still affecting the scale Y and Z of the bind joints, right? Which is not something that we are interested to see. As well as this volume multiplier, still it's affecting the scale of the joint. So when we are in FK mode, we no longer want to have the IK controller to influence the scale of the joints. And again, that's only because we directly connected the result of this multiply divide node to the bind joints. We did not consider the IK-FK switch here at all. So to solve that, I'm going to use the IK-FK switch here and blend between two values. The value that I want to get for the scale Y and Z of these joints is either 1, which is in FK mode, or it's going to be the result of this divide node. So I'm going to use a switch, and I'm going to switch between these two inputs, between these two states of values for the scale Y and Z of these joints. So in order to create that switch, I'm going to use the color blend node, or blend colors, yeah. All right. The blend colors node gets two inputs, and depending on the switch, which is called blender, it will give us either the color 1 or 2 or something between them. So using this switch, we can decide which one of these colors we want to get as the output. And they are named color. However, as just like any other node that we create inside Maya, color values are actually inputs or outputs that are having 3 different values. This is just like X, Y, and Z axis. So we can treat them as float variables as well. So again, going back to the concept, we either want to have these joints to have a scale of 1 or the result of this. So one of the inputs here is going to be a value of 1, which is a white color, or I can just type in 1 for these values. These are the RGB values for color 2 inputs. And color 1 input, it can be the result of this divide node. So I'm going to use this and plug it into color R or any other channels that we want to have to be output of this blend colors node. All right. And again, we want to control this behavior by this blender switch. So we are going to use the IK-FK switch here, and we are going to connect it to the blender. And now, depending on the IK-FK mode, we go either by this one or this one, which is either 1 or this value. So the output here is going to be connected to the scale Y and Z of these joints. So now I'm going to delete all of these connections that we have previously created. I'm going to select them and hit delete. And I'm going to go back to my node script editor. And this time, rather than directly connecting the result of this node, I'm going to connect the result of this node. So I'm going to copy the name, paste it here. Also, the output X now is changed. The name of it is changed to output R. So I'm going to rename this output R. And it's going to be connected to the scale Y and Z of all the selected joints, which are the bind joints. I'm going to select the joints, highlight these lines, run the code, it will make the connection, no error, which is good. And now if I go back and test it, when I'm in IK mode, everything is working, it's stretching, squashing, and also this volume multiplier is working. All right, so let's type in 1 here. However, if I go back to FK mode, everything is going to go back to a default value of 1 for the scale Y and Z of the bind joint, which means that if I play with this controller, it will no longer affect those joints in the FK mode. Again, we are moving the IK control, we are moving the IK controller, but we are in FK mode, so it's not affecting the joints at all anymore. One minor thing here is that I'm using the IK attribute. So you have to consider, if you are having an attribute named FK, you have to make sure that you're choosing the right values here or right inputs here, and I mean it will change the behavior of your blender. So you have to make sure that either you're using color 2 or color 1, and for having a default value of 1 for your joints. So that's one minor thing that you should keep in mind. Other than that, I guess that's about it. And we can go back to the default pose for the IK controller, and everything is all set.